Alright, P-Force, now let's look at the word problems. For question 37, we have Xing Yi who bought 1 pen and 2 books for a total of $17. And we know that a pen costs $4 less than a book. We need to find the cost of 1 pen. So we can use a model for this. We have 1 pen and 2 books. A pen costs $4 less, so a book could cost so much. And a pen will cost $4 less. Okay, so this is also $4 less. And the total cost is $17. So if we want to be able to divide by 3, we must first get rid of these 2 extra $4, and then we will have 3 units. So we can take $17 minus $4 will give me $9. This is the cost of 3 pens. Okay. And so 1 pen will be $9 divided by 3 will give me $3. Okay. So the pen costs $3. So how can we check our work? So if the pen costs $3, the book would cost $7 and $7. And 7 plus 7 plus 3 will give us $17. So it all makes sense. Next up is question 38. In the box, we have red buttons, white buttons, and black buttons. So I'm going to label this as R, white as W, and black as B. 1/6 of the buttons are black. And here we have a box of 6 squares. So we can say that 1 out of 6 units is black. And there are 12 more red buttons than white buttons. Okay. And this is the important key part. The number of black buttons is the same as the number of white buttons. So we can put it here as well. Black is 1 unit, white is 1 unit, which means that red buttons would be the rest. Red, 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 red. Okay. So what fraction of the buttons are white? So that would be 1/6 as well, the same as the number of black buttons. So shade the diagram. So using a pencil, you can shade 1 square, any 1 square. Okay, and remember, shading should always be done with pencil. So now we come to B. How many red buttons are there? So we know that for red, we have 4 units. 1, 2, 3, and 4. And for white buttons, there is 1 unit. And there are 12 more buttons. So 1 unit is 12 divided by 3, which will give you 4. So 4, 4, 4, 4. All together, you will have 16 red buttons. Okay, 16 red buttons. Okay, so that's your answer for B. Moving on to question 39, we have a rectangle. The sum of angle W and angle X is 68 degrees. Angle W is the same as angle Y. So first question, we need to find angle Y, this angle here. Okay, so these 2 angles is 68 degrees. So to find angle Y, we would take 90 degrees, this being a right angle, minus 68 degrees, you will get 22 degrees. So angle Y is 22 degrees. And what about angle X, which we will use pink for this? So W is the same as Y. So if Y is 22 degrees, W is also 22 degrees. And so x would be 68 degrees minus 22 degrees, which will give you 46 degrees. So x is 46 degrees. And to check, we can add all three together and we should get 90 degrees back. So A, angle y, 22 degrees, angle x, 46 degrees. Now for question 40. Raja leaves his house at 1315 hours. And the journey takes 50 minutes. So A, what time will Raja reach the meeting place? Okay, what time? So we have a timeline. He leaves his house at 13:15 hours or 1315 hours. And the journey is going to take 50 minutes. Okay, 50 minutes. So if we add the two together, you will get 1405 hours. So he will reach the meeting place at 1405 hours for A. Now for B. His house clock is 25 minutes slower than the meeting time. So if the clock is slower, that means the time is actually earlier. And the actual time he reached will be later. So we are going to add another 25 minutes here. Okay, so 25 minutes for B, and it will be 14:30. Okay, so for B, he will actually reach the meeting place at 14:30 hours, although from his own clock he will think that it is 14:05. So he will actually be 25 minutes later than he thinks he is. Question 41 is a question on graphs. We have the number of children who like sports. There's athletics, like track and field, running, badminton, tchoukball, and soccer, as well as the number of girls and the number of boys who like playing them. Okay, so here below the graph, we see the number of boys who like the sports. Okay, boys. So we have 75 for athletics, 85 for badminton. Tchoukball is not shown, and soccer is 75. Okay. 145 children like badminton. So we don't know how many girls like badminton, but we know that the total is 145. So how many girls like badminton? We would take 145 minus the number of boys who like badminton, which is 85. You will get 60 girls. So for A, 60 girls like badminton. B, there are a total of 270 boys. So that means all the boys added together will give us 270. Okay, so moving down, we have 75 for athletics, 85 for badminton, and 75 for soccer. We will get 235 boys. So how many boys like tchoukball? We will take 270 minus 235. You will get 35 boys. But this is not the answer yet. We will need to draw it in a graph here. So this is 25. This is 30. And this would be 35. So we're going to draw a line all the way here. Okay, so draw using a ruler, draw a straight line across. Then draw the line down to complete it. You will not need to shade the graph. Okay, just use your pencil and draw a thick line like this, and that will be your answer for B. Okay, 35 boys. Okay, moving on to question 42. Helen has 300 more stickers than coins in her collection. 300 more. If she gives away means minus okay, 172 stickers, she will have 3 times as many stickers as coins. So let's show a model with this stickers, coins. 3 times, so 3 units for the stickers, 1, 2, and 3. Coins is 1. And this is after giving away 172 stickers. I'm going to draw one longer model, maybe using blue here. One longer model here, 172. And everything from the start is supposed to be 300 more. So we will need to find 1 unit to find how many coins she has at the start. So we can see here that there is 2 units, but what's the value of 2 units? So we will need to get rid of this extra 172. So 300 minus 172 will give me 128, which is these 2 units here. So to find 1 unit, 128 divided by 2, 64. So this is 64, this is 64. So A, she has 64 coins. B, how many stickers does she have altogether? You will need to find everything. Okay, so we have 364. So 300 plus 64 will give me 364 stickers. So 64 coins for A, 364 stickers for B. Question 43 is an interesting one. The total mass of, we have a basket and a watermelon, together is 6.35 kg. Then we add some apples to the basket and the total mass is now 8.4 kg. What we do know is that the watermelon is 3 times the mass of the apples. So for A, how heavy are the apples? And B, how heavy is the empty basket? Okay. So we have the watermelon, which I will express with W. It is 3 times as heavy as the apples. So 3 units for watermelon, 1 unit for the apple. And then we have a basket that we don't know how heavy it is. Okay, so let's just draw a random bar here. The total mass of this is 6.35 and the total mass of everything is 8.4. So we could find the mass of one apple, which is to find the difference. So 8.4 minus 6.35 will give us 2.05 kg. So the mass of the apple is 2.05 kg. Then what is the mass of the basket? We can find the mass of the apples and the watermelon. So this is 2.05, 2.05, 2.05. From here, there are 2 ways of solving it, but I can take 2.05 times 3 will give me 6.15 kg. This is the mass of the watermelon. And to find the mass of the basket, 6.35 minus 6.15, 0.2 kilogram, which is also 200 gram, but I think we can just leave our answer as this. So 2.05 kilogram for the apples and 0.2 kilogram for the basket. Now we come to question 44. We have a big rectangle that measures 26 cm by 18 cm. So 26 cm is the length, as you can see here, and 18 cm is the breadth. 5 small squares are cut out from the figure. So what's the area of the remaining figure? So to solve A, we need to find the area of the big rectangle first, okay, which is 26 times 18. So I'm going to do the math by the side here. 48, 208, 0, 6, 2. So 468. This is the area of the big rectangle. And now we have to subtract the area of the 5 squares. 3, 4, 5. And the area of each square is 2 by 2, which is 4. So this is 4, 4, 4, 4, 4, which is 20. So I will take 468 minus 20 will give me 448 square centimeters. This is our answer for A, 448 square centimeters. Now moving back to B, find the perimeter of the remaining figure. Okay, so let me just erase all this part here. Okay, so if you can see, I can actually move this line up here to form a full rectangle. Move this up here to form a full rectangle. I can move this line out here, and I can move this line out here. So it's basically the perimeter of the rectangle plus these two lines. This one line in red, 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 and red. And the sides will be 2, 2, 4, 4. So I will find the perimeter of the whole rectangle, then add 2, 2, 4, and 4. So let's see. Okay, perimeter of big rectangle is 26 plus 18 plus 26 plus 18. This will give me 88 cm. Okay, then 88 or plus 2 plus 2 plus 4 plus 4. Okay, so plus 2 plus 2 plus 4 plus 4. This will give me 88 plus 12, 100 centimeters. So B, the perimeter of the figure is 100 centimeters.